In this video, I want to show how we get the formula for the Polygon interior angles sum theorem, and I'm going to develop it from the ideas of an arithmetic sequence. So in Algebra 1, you should have developed an idea of what an arithmetic sequence is and the general formula that goes along with that. So let's recall that an arithmetic sequence is some sequence of values, and as they progress, they have a common difference. And this will lead us to the formula that the nth term will be determined by the first term plus the common difference times n minus 1. And so we're going to use this to develop our idea about polygons. So in the plane, the first polygon that we have is the triangle. And then we move on to quadrilaterals and to pentagons, hexagons, and so forth. So the triangle is our basic idea here, and it has 180 degrees. If you look at the square or the rectangle or quadrilateral that you have, it is really two triangles together, so we have a total of 360. If you start at a vertex and add in the diagonals here, we see that the pentagon is made up of three triangles, and so it has 540 degrees. And this pattern continues. This is an arithmetic sequence. Each of these terms is the next 180 added to it. So it has the common difference that we need, and it has some starting term. The nth term is whatever polygon we need down the line, and we drop that number in, and this formula will tell us something. The problem with this is triangles are polygons with three vertices, and we would love to have a formula that says that when I put in the three vertices that I have, it tells me the sum of the angles there. So I'm going to modify this sequence a little bit so that I can shift my sequence. I want to shift it two places to the left so that the third term sets in one-to-one correspondence with the 180 degrees. So in other words, I really want this sequence to be shifted so this is a sub 3, a sub 4, a sub 5, and so on, so that the nth term coincides with the vertices of the polygon. All right, with this in mind, we need extra terms out here of a sub 2 and a sub 1 to fill out this sequence. So since moving to the right is the addition of 180 degrees, moving to the left will be the subtraction of 180 degrees. So 180 degrees minus 180 degrees will give us 0 for this term, and then 0 minus 180 degrees will give us negative 180 degrees. So in my new modified sequence, my a sub 1 term is going to be negative 180 degrees, and then our subscripts starting with our triangle will line up with being the nth term. So plugging this new information in, the a sub n will equal negative 180 degrees plus 180 degrees times n minus 1. And now we are going to simplify this equation. So distributive property will give us that we have 180n minus 180. And then we're going to bring our like terms together. So we're going to have negative 360 plus 180n. And then I'm going to factor out 180. So 180 minus 2 plus n. Now I'm just going to commute these terms so that I have 180 times n minus 2. And this is the formula that we need. This will be the formula that tells us the interior angle measure for our polygons in the plane, starting with the triangle and moving towards the n-gon, whatever polygon that you need moving forward. This is our polygon interior angle sum theorem. And so this n is the number of vertices that you have in your polygon.